Okay, this is the Chapter 2 review, beginning of the school year. All right, we just talked about, very quickly, open, true, and false statements. So an open set statement is something that has a variable, like 3x plus 5 equals 10. A true statement is something where there's no variable, and you have something like 2 plus 3 is equal to 4 plus 1. The statement is true. And then we have a false statement, which would be something like 2 plus 3 equals 3 times 2. Okay? So these are, all they're asking us to do is to identify, is it open, true, or false? Okay.
Mr. Masaki, they said you're supposed to record.
All right, so those are the three things that we talked about. All right, absolute value. What does absolute value mean? I will repeat you so the recording can hear. Jaden.
How far away the number is from the zero on a number line.
Distance from zero. So when I'm looking for the absolute value of negative 3 and 8/10, what is the distance from zero? Yes? 3 and 8/10. Good. And the distance, and the absolute value of 75. Somebody else? 75. And the absolute value of negative 4/10. Yes. Positive 4/10. So it's not the opposite, it's just the positive value. Because absolute value, if this is 0 and this is negative 3 and 8/10, if I took a ruler, it's the measurement from 0 to negative 3 and 8/10. And there are no negative rulers. Is that clear? So it's always, absolute value is always positive. Generally, we use this symbol. It should be in this symbol. That means absolute value. What is the distance from 0? Okay? Questions? All right, next part. How do we write a true sentence? What would make this a true sentence? Number 4. Yes. What's your name? Lilith. A greater than symbol. What about for number 5, please? How about Hallie?
For number 5, you would write a greater than symbol?
Yes, because it's really, if I make the same equivalent amount of digits, the smaller number when they're negative is actually bigger. There we go. All right, how would we do number 6? How would we do number 6? I've got the absolute value of negative 7 plus the absolute value of negative 15. Oops, sorry, that's not supposed to be a... There we go. James.
Well, the answer is...
I want to know, what do I do first?
Oh, what do you do first? You make them both positive because they're in the absolute value bar.
Right, I take the absolute value of negative 7 is 7, and the absolute value of negative 15 is
15.
And the value of it altogether is
22.
Good. Okay, so what if I made this more difficult? Okay, and I did something like this. Okay, what would we do first? This is a good example to have written in your journal to know about. Yes, Andrew?
What you would do is you do what's inside the absolute value bar first.
Good, and so inside the first one, the operation, what is it equal to?
It equals to negative 5.
Absolute value of negative 5 plus 4 times the absolute value of negative 3. Okay, next step.
Next step, you would multiply 4 something.
Before that, what do I get rid of my absolute value?
You get rid of you put your absolute values, which would be 5 plus 4 times.
And this means being next to, right here, this means multiplication. So we take the absolute value of the negative 3. And what is that? 3. And because it's next to, it means multiply. Okay? Now what do we do?
You would multiply 4 and 3, which would be 12. So it'd be 5 plus 12.
Perfect. And we get 17. It would not be uncommon for me to give you a problem like this on your chapter test. All right? Absolute value. Next. Opposites, additive inverses. Additive inverses are equivalent to what? When I take additive inverses, when I take additive inverses, what do they sum to?
The opposite of.
What is the sum of additive inverses? Always, always, always.
0.
0. They will always equal 0. So what is the additive inverse of 11? How about Sarah? Good. It's negative 11. What is the additive inverse of negative 7? Right here in the purple, what's your name?
Chloe,
Chloe?
it would be positive 7.
Good. Positive 7. The additive inverse of additive, adding, the opposite, inverse. Okay, right here, Abercrombie.
Well, it would be 0.
For number 3? 0, you said? What number is that? Can you say that number?
Negative 0.3. So
Neg-
positive 0.3.
Right, but we say 3/10. Negative 0 and 3/10, so the additive inverse is positive 3/10. And the last one, yes, in the corner there? Negative 3/4. Do you understand the idea of additive inverses? When we put them together, they equal 0. Okay, moving on. Can I skip the negative positives? Because it's 6th grade work, and this is all up here. Okay? Especially for adding, you know? If they're the same sign, we add them. If they're different signs, we're really subtracting them. And whatever you have a greater amount of is what it takes the sign of. When we have fractions, when I have fractions, what's the rule for adding and subtracting fractions? Sarah. Common denominator. So in the first one, what would I multiply it by to get a common denominator? Over 5 over 5. I really need that fancy one. I use the identity property. On the other one, I'm multiplying by 3 over 3. What that's giving me, whoops, that's supposed to be like that. I'm just not changing their values because I'm just multiplying by 1. So my new numerator here will be negative 10 over 15 plus 9 over 15. If I want to get a little bit lazy, I can write this, negative 10 plus 9 over 15. I can skip this step. I don't need to write both steps. I can do one or the other, as long as it's all over the same thing. And that adds to negative 1 over 15. Are you guys remembering how to do fractions? Yeah. Okay, moving on. Remember when we have the double negatives, that really is a positive, right? Subtracting fractions, same thing. Multiplying fractions with signs. Remember, if there's an odd number of signs, the answer is going to be an odd number of negatives, the answer is going to be negative. If there's an even number, it will end up being positive. Multiplying fractions. I'm really doing what? Do I need a common denominator? No. Multiply straight across. If you can, cross cancel. We can cross cancel. And then I'm left with negative 2 over 5. Otherwise, if I can't cross cancel, I just multiply straight across. Negative 6. Oops. I really shouldn't be adding equal signs. Negative 6 over 15, and then reduce it. 3 goes into that 2 times, and this is 5 times. All fractions are expected to be reduced unless you have that situation where they ask you to find something, unless you have the situation where they ask you to find an equivalent equation. That shouldn't be, like, right, an equivalent expression, fraction, okay? Dividing, same thing with the signs, but dividing fractions, what's the rule, please? Dividing fractions, what's the rule?
You have to flip the second one over to get the reciprocal.
And the math terminology that we use?
Oh, what?
Multiply by the reciprocal, 5 over 3. And then multiply straight across, negative 10 over 9. Leave it improper. Leave it. Don't do extra work. I'm not into taking your extra time. Get used to working with reduced improper fractions. And non-reduced improper would be this. 2 goes into that 4 times. This is a reduced improper. We like reduced impropers in algebra. Okay. You guys have the homework for tonight, and we will finish this up afterwards. All right, reciprocals. What is a reciprocal? Jack? The opposite or the flip. Okay, not the opposite sign. It's the flip. So what would the reciprocal of number 1 be? Rachel? Good. The reciprocal of negative 22. Tony?
1 over negative 22.
Good. The reciprocal of 3 3/4. Jasmine? 4 over 15, because I have to convert it to an improper. It's 15 over 4, and then I reciprocate it. Okay. The reciprocal, Vivian?
Negative 7y over 11.
Negative 7y over 11x. Questions? Moving on. Okay, I'm going to skip this. Okay, combining like terms. Combining like terms. Okay, combining like terms. Remember, the sign travels with it. So if there's multiple signs, turn it into one sign. Okay? Remember, you can do this how you want to do it. I would do something for yourself. One teacher made you circle them, or, you can do it that way, and so then it becomes positive 3x. And sometimes people do different shapes. We have positive 4y. Okay? You guys good with that? Do I need to keep going? All right. If Miss Sophia does it when she learned that I'm going to take all my x's and I'm going to underline once, and so that makes negative 10x. And I guess it would be 10x minus 2. It's negative 8x. Never mind, that didn't work. Miss Sophia, so it would be negative 8x. Okay? Miss Sophia was taught when you have two variables, like for the A's, put one line. It's 2a. With the B's, do 2 lines. I don't care how you do it as long as you're keeping track some way. It's going to be plus 4B's. Then you make sure you've hit everything. I kind of like her lines. It's clean. All right, moving on. Let's do distributing. We talked about that the other day. We can distribute a decimal. When we distribute, if the sign, like on number 6, whatever, if it's really long and 6 has a negative in front of it, that negative travels with it because 6 owns it. Whatever is to the left of the number is owned by the number. So that would be negative 12e, negative 12e plus 18f and plus 6g. Is that clear? Okay. If I have a negative, it is implied that what number is there before the negative? A 1. So it's negative 1 times 2y is negative 2y and negative 3. Got it? Questions? If I'm distributing negative a, positive 2, is everybody clear on that? Okay. Let me go to one more. Shh. Factoring, we briefly covered. Remember, what number does both terms have in common? We have a 3. What's left? Z minus y. So we divide it out, put it on the outside. Shh. Okay, last one. Let's look at number 2. Notice, there is, or we can look at number 1. So stop. The negative must be distributed first. So I get negative x, negative 1, and a 3. Now I combine 2, and I have negative x and positive 2. Okay? Homework is on the board. You're doing page 110, number 1 through 55.